My involvement in e-Agri, it really stems from a project we have with partners in Colombia looking at coffee production. So my background is I'm a biochemical engineer, so I'm interested in fermentation processes, and throughout the process of actually making coffee and going from the cherries that we pick to the roasted ground coffee that we then brew, fermentation is actually a very important part of that. So in this Newton Caldus British Council funded project, we're actually looking at how we can improve the quality of coffee by improving the processing, looking at understanding first of all how the fermentation affects the chemistry, so the chemical composition of the coffee, and then once we know that, trying to come up with simple and low cost farm-based solutions to enable and give the Colombian coffee farmers some sort of idea of how the process is performing, and more indication of whether they're going to get high quality coffee and hence high value coffee at the end of the process or not. So the project's really focused on smallholder coffee farmers. So in Colombia they have different grades of coffee production, and there's the high-end coffee they call specialty coffee, and that's grown by smallholder coffee farmers. So they're usually small family-owned coffee farms, and on the farm they grow and they have a couple of harvests a year, so it's quite small production volumes. And the problem at the moment, and it's kind of a societal challenge that we're addressing really, and the issue is that the coffee farmers, they're in cooperatives, and so they have a cooperative, and then that takes care of the roasting. But it's only when the coffee's been roasted and gets to a tasting panel that the quality characteristics get fully determined, and then that ascribes a value to the coffee. So it's only after the coffee's left the farm gate that the farmers actually find out whether they've got specialty, high quality coffee or not, and hence how much they get paid. And so that if you're a smallholder Colombian coffee farmer, that can make a very big difference to your bottom line, and whether you have enough money or not, essentially. And so really we're interested in coming up with some small handheld devices that enable farmers to actually get some process information so that they can have some idea before the tasting panel, before the coffee's left the farm, of what sort of quality coffee they've got and hence what price that will get. So at the moment, for the current project, we've taken samples from the coffee farms of both the green almond coffee, so that's after it's been fermented, and we've got samples that have been fermented for different amounts of time. And we've got the roasted coffee as well, and we've shipped them back over here. And my part of the work is actually doing a lot of analytical chemistry as well. So we're doing a lot of complex analysis to understand how the chemical composition of the coffee changes with the fermentation process, and where the sources of variability in the process are, so we can start to control those. So this research involves myself and Professor Bruce Grieve, directly working on the Newton Caldus project here in the University of Manchester. So I'm in the School of Chemical Engineering and Analytical Science. Bruce is in EEE. Then I have a postdoc as well, called Sean. So he's actually doing a lot of the analytical work on the coffee. And then in Colombia, we have project partners in Universidad de los Andes in Bogotá. And then we also have collaborators in Universidad Surcolombiana, which is in a region called Huila in the south of Colombia, and that's actually a coffee growing region, so that gives us the contact with the coffee farmers. So it's actually quite a big project, and has quite a broad reach, and especially in Universidad Surcolombiana, they actually have a coffee processing pilot plant there, so they can replicate all the on-farm processes in the university, where we can get more process information and start to get more understanding of what's happening. So that's really why the collaboration is an effective thing, because it gives us not only access to the coffee and the exchange of knowledge, but also there's these coffee processing facilities as well. So I actually have an MSc student working on part of the roasted coffee analysis, looking at the volatile aroma compounds that come off the roasted coffee beans, and that's a current master's project at the moment. And there's plans to have some student exchanges as well of PhD students and maybe master students as well from Colombia coming here. So that's kind of, again, the knowledge transfer part of the project, and knowledge exchange and actually people exchange as well. I suppose the thing, so as a chemical engineer or a biochemical engineer, I'm interested in processes wherever they occur and processes that make things that people need. And so I think there's a need for process engineering, biochemical engineering, chemical engineering across kind of the whole e-Agri sector. Because anything where we're doing any sort of processing, we really need to be able to understand that and actually think at a process level, looking at how systems operate. And that doesn't just mean in how we take coffee, pick the cherries, and actually end up with the final coffee product that you can go and buy in a shop and drink. It also means thinking on a higher level about how supply chains operate, life cycle analysis, things like that. So I guess my end point is that that kind of chemical engineering input and expertise and process knowledge is actually key to understanding and unpicking a lot of the themes in kind of the e-Agri challenge areas.